Hi, this tutorial covers positive and negative correlations. Okay, so let's recall the correlation coefficient is abbreviated as R, and that measures the direction and the strength of a linear association. Okay, so remember that direction of a linear association is negative, and then the strength of a linear association can either be weak, moderate, or strong. Okay, so what we're going to do now is now that you have some experience calculating R, you want to be able to interpret R. So you want to be able to see, well, based on my value of R, is it positive or a negative association, and then is it a weak, a moderate, or a strong association? So here's kind of the breakdown for how to interpret R. That there's some symmetry here. And basically, anytime you have an R value that's negative, you're going to have a negative association. Anytime it's positive, you're going to have a positive association. So that works out nicely. Now, if it's within 0.5 of 0, it's going to be considered weak. Either weak negative or weak positive. So weak positive if it's from 0 to 0.5, and weak negative if it's from negative 0.5 to 0. Okay, so anything close to 0, within 0.5 of 0 is going to be considered weak. Okay, now if it's 0.5 to 0.8, so if it's right on the boundary of 0.5, then it's considered a moderate positive association. If it's from negative 0.8 to negative 0.5, then it's a moderate negative association. Okay, then anything from 0.8 to 1 is a strong positive association, and anything from negative 1 to negative 0.8 is a strong negative association. Okay, so really the important boundaries to remember are 0.5 and 0.8. And then if it's equal to 1 or equal to negative 1, then it's either a perfect positive association or a perfect negative association. Okay, so just to make sure we have a good definition of positive correlation and negative correlation. Positive correlation is the type of correlation present when two variables have a positive correlation coefficient that is not near 0. Okay, negative correlation, type of correlation present when the two variables have a negative correlation coefficient that is not near 0. Okay, so this is basically R greater than 0. This is basically R less than 0. And then relatively zero correlation, any type of correlation present when two variables have a correlation coefficient that is close to 0. Okay, so if R is approximately equal to 0. Now let's take a look at a couple different graphs that have some different R values. If R is equal to negative 0.9, okay, that's a strong negative association. So as X increases, Y decreases. Now, they're pretty close to that straight line. There is a little bit of scatter about the line, but they're pretty aligned. Okay, negative 0.5, this is technically a moderate negative association. It's right on the boundary of weak and moderate. Now we can see still a pretty clear negative association, but the lines are a little more scattered, or excuse me, the dots are a little more scattered about the line. Okay, R equals 0, that's basically just a cloud of points. Now looking at R equals positive 0.5, that's pretty similar to negative 0.5, but now you can see is that as X increases, Y is increasing also. So it's pretty similar, both moderate, but this one is positive. Okay, this is R equals positive 0.9. Okay, again, we can see that's pretty similar to this one. Okay, this is the one as though Y is increasing as X is increasing. And then this last one, R is equal to 1. This is a perfect positive association. You kind of have that perfect linear relationship there. Okay, let's look at another scatter plot here. So the scatter plot below shows X, which is the height in inches, and Y is the average weight in pounds for American females 30 to 39. Okay, now if we tried to calculate the correlation coefficient here, we would probably get a value probably above 0.9. So it's going to be a really strong association. Now the issue with this one is that I would propose that this is, instead of being linear, this is probably a nonlinear relationship. We can see that it does seem to have this curve to it. Okay, it'd be better to fit a slight curve than a straight line. So it would not be appropriate to calculate R here. Okay. So this was an example of a nonlinear relationship, and they are associations between two variables that can be modeled better with a curve than a line. Use of the term correlation and the calculation of the correlation coefficient should not be applied to nonlinear relationships. Okay, so correlation and correlation coefficient are reserved for linear relationships only. Okay, so it'd be inappropriate to apply it to that height and weight example. All right, this has been your tutorial on positive and negative correlations. Thanks for watching.